Congratulations! You've completed the first and second chapter of chemistry. But now it's important to connect all the big ideas to one another. Through this video, I'm going to kind of review all the big ideas and tell you what you kind of need to know for the test. Let's just dive right into it. First, it's vital to understand what matter is. So matter is anything that both takes up mass and both takes up space. And the whole first few chapters are about matter, how it behaves in the natural world, and so on and so forth. Chemistry, which is the course that you are presently taking, is all about the study of matter. Chemistry is about matter. Everything that involves is about matter. So think of chemistry, what you are currently studying is the study of matter and the change that it undergoes. Because everything in this natural world, your being is matter. Now I'm kind of going to go over the different branches of chemistry and how we can kind of separate into all these different areas. Chemistry is a natural science, but more specifically, it can be divided into being a physical science. Other, subjects like that would be physics. The next idea is that chemistry can be divided into being pure and applied. So what does pure chemistry mean? So pure chemistry is the pursuit of chemistry to attain knowledge about it. Versus applied chemistry is using that knowledge that we gained from pure chemistry and applying it to something else. There are other branches of chemistry from there. Chemistry can be divided into being organic and inorganic. So organic chemistry means dealing with stuff that contains carbon, such as CH3. Inorganic stuff does not contain carbon, so that'd be like NaCl. This year in chemistry, we're mainly going to be studying inorganic chemistry. Chemistry can also be more classified into biochemistry, which both combines biology into chemistry into one amazing study, and it's about studying the process that occurs within living organisms. And then your last two studies are analytical and physical. So analytical chemistry is all about the study of the composition of matter, which is how we most commonly, what our most common definition of what chemistry is. And our second definition is about physical chemistry. So physical chemistry is about the energy transfers that occur when matter changes. So you could think of this when solid. So let's think of an ice cube, and then when that becomes water. So when that matter changes, the study of that energy that is associated with that change from one state of matter to another can be classified as physical chemistry. Another important idea to make sure you are prepared on and have a vast knowledge on is the history of chemistry. Just kind of brief over your study of chemistry, you'll better understand more about the history and how other ideas in chemistry have developed. But just for the sake of the test, the early ideas of chemistry could be classified into alchemy. So the ideas of alchemy were to change, simple, crappy metals into gold and other really valuable other valuable measures. Was to find something that would be similar to a fountain of youth, eternal perfection. Fountain of youth. Something to cure all diseases. Cure all. Alchemy, though, changed as the result of Antonio Lavoisier. That's a really important name to memorize. So he changed chemistry into being more analytic. So chem to being more analytic. He developed the first real balance that was extremely very specific. I believe it went up to 0.001. And he is really what made chemistry about measurement and precision and everything that chemistry is today. So just think about chemistry going from alchemy with hopes of curing all disease and stuff like that to chemistry being about measurement and design. The next idea to review is the scientific method itself. Many of you remember this from biology, but it first begins with making an observation. So observing what's going on around in the natural world. And then making a hypothesis. So a hypothesis is basically just a question, questioning an idea of why is this observation that you're seeing happening. Then after that, you take your hypothesis and you try and test it using an experiment. So an experiment is all about testing. Once you've done your experiment, you'll get a set of data. And you'll use that data to form a conclusion. Were you right or were you wrong? And if you were wrong, where do you go from there? How can you revise what you saw into a different hypothesis and continue testing that again? That's what chemistry is all about. No one discovered the proton and how it existed. No one discovered DNA just on their first hypothesis and its structure. And, eventually you'll end up at a theory. So a theory is a well-tested explanation for a very broad set. So that means you got to look at a bunch of stuff. So a very broad set of observations. And then, eventually you could end up having a scientific law. So a scientific law states a relationship. When in comparison, if we're comparing a theory to a law, a theory cannot be definitely proven. It's like the atomic theory and stuff like that. Those cannot be definitely proven, but through our broad set of observations, they seem to be true. But other further evidence may change that. But a scientific law states a relationship, and it provides no explanation why. Now let's dive a little bit more again into matter again. So the three states of matter, as many of you know, are a solid, a liquid, and a gas. They're discovering new states of matter, but those really are not important for the test. So I'm just going to stick with those. A solid, it's got a very definite shape with all the atoms and molecules in a very orderly pattern. A liquid, is very flowy. It's like water. And a gas is like everything that's around us. Also, to add to this discussion, wink, wink, this I think was on the test of what a vapor is. Star this, key this, remember this. A vapor is a gaseous state of a liquid. Liquid, remember that. It's a gaseous state of a liquid. Liquid, star that, of a liquid. Okay? Now let's go on. There are both extensive properties and intensive properties of matter. Intensive and extensive. Well, what are those? So an intensive property doesn't depend on amount of matter, does not depend on amount. It just depends on type. What type of matter you have. Do you have a solid? Do you have a liquid? Do you have a metal? Do you have a non-metal? Do you have a metalloid? What do you have? And when you're associating with some intensive properties, you can think of boiling point, melting point, malleability, ductility, and so on and so forth. So those all depend on the boiling point is specific for that type of substance. First, in comparison with an extensive property, it depends on the amount of matter you have. So amount of matter. So this could include like mass, length, and volume. The next are physical and chemical properties. So a physical property can be observed without seeing the substance, observed without substance. So this could include like its mass and its density. You can both look on a piece of paper and see those. You don't need necessarily see the substance to know what its mass would be or to know what its density would be. Versus in turn for a chemical property, these are properties that can only be seen by either altering the composition of the substance or seeing the identity of the substance. So this could include its color, its reactivity with water, if it's soluble, does it burn, does it rust. So it's both the property that can be observed by either altering or seeing the identity of the substance, but it also can determine how well it reacts with others. The next idea is a physical change in matter or a chemical change. So for a physical change, it's a change that occurs. So it's a change, let's draw it up here, change that occurs without altering the chemical composition or identity. So most common of this would be changes in states of matter. When you're going from, say here, if we're thinking about an ice cube here, my beautiful little cube, when this ice cube is changing into some water over here, the H2O, which water is made of, it's not changing its substance. It's just changing its shape. The molecules inside the water are just adjusting. It's not changing its complete chemical identity. Water is not becoming. It's not developing different characteristics. It's not developing the conductivity of, say, copper or anything like that. Anything else. It's just changing its shape. So physical changes are all about changes that occur without altering the chemical composition or identity of the substance in that sense. Also including this would be dissolving something, but in this case, just think physical change, changes in state. The next one would be a chemical change. So what a chemical change is all about, there's 4 signs of a chemical change. There's a color change. So a color change, so your substance goes from colorless to pink. There's gas given off. There's a transfer of energy. And there's the formation of a solid. And if you want a hard, fast definition, a chemical change alters the chemical composition, but another definition would be it changes one substance to another with new properties. And some words associated with it that, they could ask, is this a chemical change or a physical change? You'll commonly see the words like burning, rusting, and stuff like that, where it's changing from one substance into another. So through those, and it can't go back. One last idea with all these is the law of conservation of mass. Law of conservation of mass, which states that matter can be neither created nor destroyed. Okay? No matter can be created or destroyed. Boom. This will now end part 1 of the video. Go check out part 2 now.